Have you ever wondered what everything is made of? Why do things exist as they do? These are not merely the musings of a curious mind, but the foundation of inquiries that drive the world's brightest physicists. They yearn to unravel the mysteries of existence, to comprehend the fabric of our universe. The universe, as we know it, is a grand cosmic ballet, choreographed by four fundamental forces. These forces, invisible yet omnipresent, shape the world and the cosmos, influencing everything from the smallest particles to the largest galaxies. First, there's gravity, the force that keeps us grounded, literally. It pulls objects toward each other, binding us to the Earth, and the Earth to the Sun. It's the glue that holds the universe together, yet it's the weakest of all the forces. Next, we have electromagnetism. This force is responsible for so much of what we experience daily. It lights up our world, powers our devices, and even holds the atoms in our bodies together. It's a force of incredible versatility and power, and yet it's only one part of the cosmic equation. Then there are the strong and weak nuclear forces. The strong nuclear force, as the name suggests, is the strongest of all. It binds the protons and neutrons within an atom's nucleus, overcoming the repulsive electromagnetic force. The weak nuclear force, on the other hand, is responsible for radioactive decay and nuclear fission, processes that power our sun and the stars. These four forces, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, are the architects of the universe. They govern everything from the dance of galaxies to the interactions of subatomic particles. They are the laws scripted into the very DNA of the cosmos, shaping existence as we know it. So these four fundamental forces are what govern the universe, but what are they really? Gravity, something we experience every day, but did you know it's an illusion? You see, gravity is not a force in the traditional sense. It isn't an invisible hand pulling us towards the Earth, nor is it some magnetic allure that the Earth possesses. Instead, it's something far more intriguing. It's the curvature of space-time caused by mass. Let's try to simplify this. Imagine space-time as a soft, stretchy fabric. Now, if you place a heavy object on this fabric, like a bowling ball, the fabric will sag under its weight, creating a curve. This curve is what we call gravity. So when a smaller object, say a marble, comes close to the bowling ball, it doesn't get pulled towards the bowling ball. Instead, it simply follows the curve in the fabric that the bowling ball has created. Now, apply this analogy to the universe. The bowling ball is a large mass, like a planet or a star, and the marble can be anything with less mass, like an asteroid or, in our case, humans. The fabric represents space-time. When a large mass like Earth distorts this space-time fabric, it creates a curve or a well. We, the marbles in this scenario, move along this curve. We're not being pulled down to the Earth, we're following the curve in space-time that Earth creates. But what about the feeling of being pulled down, you ask? That's just another fascinating aspect of this illusion. You see, it's not gravity that you're feeling, it's your resistance to following the curve in space-time. It's like you're continuously trying to move in a straight line, but the curvature of space-time caused by Earth's mass keeps pushing you around. So the next time you drop something, remember, it's not gravity pulling it down, it's the object following the curve in space-time that our planet creates. So, gravity isn't a force pulling us down, it's the shape of space-time pushing us around. Electromagnetism, a force we can't see but we can't live without. A pillar of the universe, electromagnetism is the invisible glue binding our daily lives together, the unseen hand guiding most phenomena we encounter. Imagine your life without light or color, those vibrant hues in a sunset, the soft glow of a lamplight, even the bright screen you're currently looking at. All of these are gifts from electromagnetism. It's the force that governs the behavior of light, allowing it to travel through the vacuum of space, to bounce off objects and to reach our eyes, enabling us to see the world in all its glory. But electromagnetism doesn't stop at the visual. It's also the lifeblood of our modern technology. Every email you send, every song you stream, every video you watch, all these are possible because of electromagnetic waves. They carry information across vast distances, connecting us in ways unimaginable just a few centuries ago. Now, let's delve deeper, to the very essence of life itself. At the heart of every cell in your body, a myriad of chemical reactions are taking place. These reactions, which keep us alive, are governed by electromagnetism. It's the force that determines how atoms bond to form molecules, how proteins fold, and how enzymes catalyze reactions. Without electromagnetism, life as we know it would simply cease to exist. And it's not just about us. Across the cosmos, electromagnetism is at work. The heat of the sun, the glow of distant stars, the beautiful colors of nebulae, all these are manifestations of electromagnetism. It's a force that transcends the boundaries of our planet, permeating the entire universe. To sum it up, electromagnetism is a universal force, silently shaping our world and beyond. It's the conductor orchestrating the symphony of life, the artist painting the canvas of the universe. It's a force we can't see, but its influence is everywhere, from the smallest atom to the largest galaxy. From the light we see to the air we breathe, electromagnetism is truly the force of life. The strong and weak nuclear forces, the hidden powerhouses of the universe. Picture a bustling city. The buildings stand tall, the traffic moves in rhythm, and everything seems to hold together in harmony. Now imagine that city is an atom, and the forces keeping it together are our invisible heroes, the strong and weak nuclear forces. To understand these, we'll need to take a deep dive into the heart of an atom. At the core, or the nucleus, we find protons and neutrons. Protons, being positively charged, should repel each other, right? So, how come they're all hanging out together in the nucleus? That's where the strong nuclear force comes in. It's like the ultimate peacekeeper, overcoming the natural repulsion between protons and holding them together. Now, the strong force is incredibly potent, but it also has an incredibly short range. It's like the introverted powerhouse of the nuclear world. If you're within its tight-knit circle, it's the strongest force you'll ever experience. But step a little away, and it's as if it doesn't exist. Then, there's the weak nuclear force, the mysterious underdog. It's much weaker than the strong force, hence the name. But don't let that fool you. The weak force is responsible for some pretty impressive phenomena like radioactive decay and nuclear fusion. Just everyday things like powering the sun and enabling life on Earth. These nuclear forces, both strong and weak, are the silent guardians of the atomic world. They're the reason why matter is stable and why we have complex structures, from tiny atoms to vast galaxies. They're responsible for nuclear reactions in the sun, giving us light and warmth. They're the reason why we can harness nuclear energy both for power and, unfortunately, for weapons. All this, yet they're so tiny and elusive that we don't see them, we don't feel them. But they're there everywhere, always working behind the scenes, holding everything together. These forces, though we don't see them, hold our world together. The universe, vast and mysterious, is governed by 4 fundamental forces. These forces, like unseen puppeteers, pull the strings of existence, dictating the behavior of every particle and celestial body in our cosmic arena. In our exploration, we've journeyed from the illusionary force of gravity to the vibrant dance of electromagnetism, and then delved into the heart of matter with the strong and weak nuclear forces. Each of these forces plays a critical role in the grand tapestry of the universe, weaving together the narrative of existence. Gravity, though it seems like the most familiar force, is actually a master of deception. It's the cosmic architect, shaping the universe on a grand scale, driving the formation of galaxies and holding planets in their orbits. Electromagnetism, on the other hand, is the life force, governing everything from the light we perceive to the bonds that hold atoms together. It's the force that makes our world colorful, tangible, and alive. The strong nuclear force, though confined within the nucleus of atoms, is the glue of the universe. It's the force that holds the nucleus together, overcoming the repulsion between protons to give birth to atoms and elements. And then, there's the weak nuclear force, the subtle shapeshifter, responsible for radioactive decay and the fusion reactions that power the sun and the stars. These 4 forces, distinct yet intertwined, are the basis of everything. They are the reason why atoms form, why stars shine, why galaxies spin. They are the melodies in the symphony of the universe, each playing their part in harmony to create the cosmic music we're all a part of. As we continue to probe the universe, we are constantly reminded of the profound interplay of these forces. They are the laws that govern the universe, the framework upon which everything is built. And so, our universe in all its wonder is a symphony of these 4 fundamental forces, playing out on the grandest stage of all.